recognized publishers such as IET, Springer, Elsevier, and CRC. Professor Singh have been recognized as world ranking of top 2 scientists in the area of biomedical research for the year 2020 and artificial intelligence image processing for the year 2020 to 2024, according to the survey given by the Stanford University, USA. So according to AD Scientific Index 2025, he is listed at 58th position, Asia top 100 engineering and technology computer science scientist in India. He has received a Royal Science Grant for the International Exchange Award for overseas travel between collaborators in UK and India in between 2012 and 2016. He is the visiting professor at Security and Optimization for Network Globe Laboratory at University of Maryland, Baltimore County, United States, and International Center for AI and Cybersecurity Research and Innovation, Asia University, Taiwan. Currently, Professor Singh is the Deputy Editor-in-Chief for IEEE Transaction on Consumer Electronics Letter, Area Editor Information Fusion, one of the highest impact factor journal in Elsevier, and member of Editorial Advisory Board of several transactions, Associate Editor of IEEE Transaction on Multimedia, IEEE Transaction on Computational Social System, Journal of Biometric Health Informatics, and several others. He's the recipient of IEEE Transaction on Multimedia Excellent Editor Award, which is a really, very good thing for an Indian. So his research interest also includes multimedia data hiding, image processing, biometrics, and cryptography. So with this short introduction, now I'd like to request sir to please start the session.
Okay, thank you. Hopefully it is showing to you all.
Sir, it is visible, sir.
Okay, thank you. So firstly, I thanks to organizing committee of this faculty development program on modern computer vision. And really, this is a good topic, and I especially thanks to Dr. Deepak who invited me for as an expert lecture under this prestigious FTP and we can say an important topic of modern computer vision. So I can choose based on the modern computer vision FTP, medical data hidings and emerging trends and research issues. Of course, deep learning is an important part of the computer vision, so I can choose my topic under this domain. And we will see under this medical data hidings how the deep learnings and AI rules are recently used by the various researchers. And we will see, of course, the deep learning is a very good and important things under this domain. So I can choose my research talk outline basis on the relevance of medical data hidings. Of course, what are the importance of medical data hidings in the, especially not in the medical field, but also in the other fields. But I chosen the data in the form of images. Why in the form of images? We will see what are the importance of images. But everyone is know that why the images are extremely important in the various applications. Major properties of data hiding in the form of robustness, imperceptibility, and key capacity. And these are the, of course, a key property. But in addition to these three property, we will see the other things. What are the interesting application under this domain? We can see under this title we what are the importance of data hidings not in the medical domain but also from software to hardware protection it is using by the various researchers. Generic framework in the form of embedding and extraction we will see. And of course there is a, if we are in the sender process and we are at the process of user, we are in the users, that's we can embed our data in the some form of cover media, and we will send the cover media to the intended receivers. But it can be it can be a various receivers in the form of one to one or one to many. Why deep learnings for the data hidings are extremely important, not in the spatial domain and transform domain, are previously used by the researchers. I am not saying that in the current days spatial domain techniques and transform domain techniques are not important for the recent time, but of course deep learning is a advanced things, and we can include in the field of data hidings. State of the art approaches, I selected some approaches where the deep learning is playing a key roles in the data hiding techniques. So that's why potential issues and possible solution we will see. Based on these potential issues and possible solution, I trust that everyone who is thinking about this topic and who is the new researcher under this topic, they can be benefited. So we can start our talk with the relevance of data hidings, and you can see the particularly multimedia contents and especially digital images are one of the most important and demanding aspects of the information era. We have many multimedia documents in the form of images, audio, video, and graphics. But out of other multimedia documents, digital images are the widely used documents, and it is an main information carrier in many potential applications like healthcare. You can say the social media, you can say the remote sensing, facial recognition, and many more. Of course, computer vision is one of them. So therefore, it is extremely important in many applications. But in the other side, if we can see, it is very important to protect the image privacy. I collected some data based on the survey, based on the published materials, and we can see the why the images are popular in the recent things, and why the images are the very important for the research domain. So according to the report, digital images processing market size is valued at the USD of 93.27 billions in 2024, and around 34 millions new AI generated images are created every day. Every day user, you can see the modern medical identity theft is the increasingly and 21st century problem, and it is the largest contributor to the fraud in India and other countries. It is established that HIPAA, I think it is a Health Insurance Portability and Accountability Act journals, and it is published in 2024. Healthcare accounted for the almost one quarter of the all data breaches. So you can think that what are the major issues of health data breaches under the healthcare domains. Copyright violation and misuse of personal and medical informations are extremely important, and these are the extremely important issues under this domain. And further, it is established that data breaches incident expose the sensitive and personal informations of over the millions of individuals. So this breaches has heightened the concern about the data security in healthcare sectors.
If possible,
And
kindly make it full screen, sir. Sorry for the interruption.
hello.
Yes, sir. If possible, sir, if I kindly make it full screen, sir.
I given the full screen, I think. Not showing to you.
I don't know about others. It's not showing to me. You can reshare, sir.
I am sharing.
Yes, sir.
So it is showing the full screen.
Participants, can you please confirm? So
Not showing?
Not showing, sir, from the chat box, what I can see.
Okay, okay. I can share my screen. I think that will be better. Share entire screen. And now,
Yes, sir. Now it is visible, sir.
now
It
it
is
is
full
good.
screen also. Yes, sir. Yes, sir.
Okay, thank you, Deep. Sorry for that. And
Apologies.
you can see the importance of the coronavirus pandemic in 2019. We can see a large number of medical images and other electronics medical records were generated and shared online on a daily basis, right? So under these trends, the medical images and other record also pose a significant privacy threats, right? And no doubt, numerous standards and guidelines issued by the different organization. I can quote the different organization: Health Insurance Portability and Accountability Act. You can say the HIPAA and Digital Imaging and Communication in Medicine, DICOM. So to ensure the security of the medical records, but it is published in many journals. None of the issued mandate or guideline have the completely addressed the all security issues in the healthcare domain. And lastly, you can see the importance of images in social media. So every day users share around the 14 billions of images via social media platform. And as of May 2024, over the 6 million photos were uploaded to the Google Photos every day. And it is reported by the Googles. So that's why images are extremely important, but their privacy protection is also equally important. So how can we protect it? So we can start the data hiding concept with some classical uh, vision problems, Siemens in 1984, and you can see the classical model of data hiding in terms of prison problems, right? So with this figure, we can see it suggests that two-person, Alice and Bobs, are arrested for the some crime and are sent into the two different cells here. And Wendy, which have the acting as a warden and has arbitrated all the communication between them, and which act as a hindrance to their escape plan. If any suspicious communication is detected by the warden, Wendy, so she will inhibit the exchange of all messages and place them in a solitary confinement. So both party must be communicate invisibly in order to arouse the warden's suspicions. So under this situation, you can see this figure, and under this figure, uh, Alice creates a picture of blue cow and lying on a green meadow and send this piece of art to the another persons. So this figure have no idea. Warden have no idea that the color of the objects in the picture and easily transmit the information to the other persons. Wow. But can you imagine that how can be information can be changed by the Wendy? It can be destroy the color object. It can be alter the color objects. So meaning will be different. So it can be act as a attackers. So data hidings it is extremely important under this situation, and this is the art of hiding data into the cover media without any the perceptual distortion of the cover message, and importantly for the purpose of identification, annotations, and copyright purposes. You can see these are the two types of data hiding techniques are extremely popular: steganography and watermarking. And steganography, that's a hiding of secret message inside the other message, and in order to avoid the other to detect or decode it. So, but mainly it is focused on the imperceptibility. We will see what are the imperceptibility in terms that we can say how can we perform some operation in the images. Let's say you are going to hide some images under the cover media, so it will not be noticeable to the other persons or any other one. So that's why we can say watermark should be done in a such a way that it will not degrade the quality of the cover media. But it is established that it is not robust against the attack. So that's why digital watermarking is important here. So under the digital watermarking techniques, any watermark, this watermarks in the form of anything, either it can be a text media, it can be a audio, video, or image media. Any media can be embedded into the host signal, and this host signal also can be any multimedia documents. So it can be robustly and invisibly at the same time. So you can compare both things here. So robustly is the included the term here, and this robust watermark means how can be registered, your algorithm is registered to the designated class of attacks. So that's why it is popular for the researcher, because it is registered to the attacks, various attacks. You can see these figures, and this figure is showing that this watermark in the banknotes and the currency, and we can see in the everyday in our life. So you can see in the first one there is a security ribbons, and there is a some persons are there. There is a bell inside and hundred of numerals. Under this other one, you can see the thousand of numerals. There is a person Mahatma Gandhi. There is a security ribbons and diamond symbol. So, but these are the visible watermark which can see clearly under the this bank notes and currencies. So, but this visible watermark is also having some drawback. We will see what are the invisible and visible watermark, and which one is extremely important for us based on the application requirement. We can see it. Major advantages of the watermarking we can see particularly in the healthcare domain. If you can see, the ownership identification and confidentiality of the data is maintained. Why the confidentiality and ownership identification is maintained? Because we are hiding the data into the cover media. So that's why if any suspicious things, any ownership conflicts are occur, then we can extract the watermark under the cover media and prove that the owners of that method. Protection against tampering is important in the healthcare domain, and protection against tampering is most important in healthcare application, as the very well, tempered data may cost the life due to the wrong diagnosis. Any bit information if you lost, then it can be a wrong diagnosis can be happens. A smaller storage space and is required for storing the image related records together, and these records in the embedded inside the images. If you can see, there is a in the under the healthcare domain, you can see the patient images, patient addresses, patient related any other informations, and you want to store separately to all the data, then it requires the storage space much as much possible. But if you can store the data under the particular images, related images, then you can say you can store your the storage requirement. At the same time, if you are sending one images at a time, individually you are sending one, two, three, four, five images at a time, and let's say you are hiding some four of images, related of images under the cover media, and then you are sending on the open channel, then it may reduce your bandwidth demand also. Next things, you can see the acting as a keyword. The hidden watermark can play a role of keyword, and based on which efficient archiving and data retrieval from the querying mechanism take place. So let's say if you have a large data sets and you want to search quickly as possible, and then you can hide data under the this watermark plays very important role as a keyword here. It provides a potential solution to the data management issues. We can relate with the healthcare domain. Why it is important here? This important because let's say you have categorized the data into two parts, important data and less important data. For example, any doctor written some solution, some diagnosis. You have a diagnosis report for you have, and then under this diagnosis report, there is a doctor signature is the most significant part of that authenticate your report is correct or not correct. So based on the choice, if doctor signature is the most important part under the report, so you can hide under the other significant part of the data in the same images. However, the less important data, let's say you can say hospital logo, or you can say patient report, then you can hide into the other part of the same media. So you can think that there is a option is that how can we hide the more important data in the some other parts of the same images. However, we can hide the less important data under the other part of the same images. So that's why we can categorize the important data and less important data. That's related to the data management issues. So you can see the major properties of the this watermarking, and these property are extremely important for the any researchers. Robustness is the property, very important property. That's any digital watermark can called the robust if it registers to the designated class of the information transformations, and it can be majorly used for the copyright protection purpose. So majorly, you can say robustness criteria focuses on the two things. Firstly, you can say whether or not the watermark is present after the distortion in the data. And secondly, you can say whether it can be detected by the watermark detectors. Imperceptibility is another property where we can say watermark should be done in a such a way that it will not degrade the quality of the cover media. And embedding capacity is also an important property because it's showing the amount of information that can be embedded into the cover. Of course, if you are doing some research in the healthcare domain and your algorithm is not embed the larger information under the same media, so that's why it is not very good for the healthcare application. So under the healthcare application, your algorithm need to hide as much as possible data under the cover media. These above three properties, robustness, imperceptibility, and capacity, which are the trade-off to each other. So researchers are struggling to balance them. How can we robustness and imperceptibility when you are going to uh, increasing any one of the property, other property will be degraded. So that's why how can we embed these three things at the same time. Security is an another part of that, and this security of the watermarks that can say the watermark should be difficult to remove or alter without damaging the cover media. Let's say most of the things are showing that the security and robustness are the same things, but I can categorize the robustness and security in the two terms. These two terms is saying that if we are embedding something, that it may possible some image processing operation, and due to this image processing operation some noise may occur automatically. It may be channel noise, it may be image processing operation noise created by the image processing operations. But under the security trends, you can any unauthorized person deliberately they can apply some standard technique, and they can deliberately remove your watermark, or they can destroy your message, all the things. So that's why this is the majorly called the security. Complexity is an another property. So computational cost is basically referred to the cost of embedding of the watermark into the cover media and extracting it from the digital cover. So in some application, it is important that embedding process be as fast, as simple, as while the extraction can be more time consuming. So you can think that, let's say you make your algorithm is more secure, but it is too complex. But if you can, another side, you can see the telemedicine applications. So your algorithm should be more secure and less complex. So this is their responsibility. How can we make it possible? So all five possible solution, all five possible property you can see here, and very few papers are published under the this data hiding domains. That's uh, make a good balance between all five property at the same time. And this is a good research questions. If anyone are thinking about the research, they can be balance a good balance between all five property at the same time. Now you can see some interesting applications. I collected them, military application to broadcast monitoring application. Not only the software part of that, but you can see one of the last four, chip and hardware protection. This is very interesting things where the data hidings are using. So intellectual property core and hardware protection through watermark is an emerging area of research. For example, you can say vendor ownership security is a very frequent problem and encounter as a part of IP core protection, and it is deal with the solution. You can say the watermarking solutions. So digital watermarking can be embedded into different level of hardware design abstraction, and it is the based on the designer's choice, where you can say the level is imposing the different trade-off choice and design overhead. So extremely important that you can think chip and hardware protection by the watermarking is a very interesting area, and you can see the paper published on that. Now the generic framework of the watermarking are here, and you can see there is a three boxes we can see here: encoder, decoder, and comparator. Under the encoder trends, this is the sender side algorithms, and images and watermark to input are given to the encoder, and it is created the M dash. However, this M dash is called the watermarked images. At the receiver side, decoder can receive the watermarked images, and this test images is called the watermarked information or any side informations. Based on the original image, you can extract the watermark W dash. And lastly, our duty is that how can we compare and how can we see what are the robustness of our algorithms. So once W dash and W are compared, extracted watermark may be distorted, so may be tempered. So W dash and W can be compared, and you can see in the form of results, in some form of performance metric, you can decide that your algorithm is robust or not robust. So of course we seen that imperceptibility and robustness properties watermark under the image M. So we can say M dash will be near similar to the M. So if your algorithm is like that, M dash is same as M, you can say your algorithm is higher imperceptible. However, if you are saying that W dash is similar to the W, then you can say your algorithm is highly robust. So that's why these are the two property are extremely important under this domain. Now you can see what are the importance of visible and invisible marked images. So I collected this figure from my papers, and you can say I1 and I2 two images are there, and where we are marked there. We are marking as a visible watermark, and you can see this visibility is given here. And again, we are given the mark information mu, and this mu information are hidden into the visible marked media. So you can say this is the watermarked images which containing the two type of watermark. First one is this one visible watermark, and this is a new information which are not visible to the human eye, but it is in the inside the images. and any ownership conflicts are there, then you can prove that who is the correct owner of that images. So that's why you can say best combination of visible or invisible watermark. And I suggest that anyone can propose not only the visible, not only the invisible, but you can think about for the medical domain. You can combine both concept, visible and invisible watermark, because both having the some merits and demerits, so you can use it for the further research. So invisible watermark can be a robust, precise and semi-precise. So under the visible watermark, you can say this type of watermark always be applied to the visible signal. You can say images and videos. However, what are the other limitations of this visible watermark? They may cause the degradation in the image quality, and it may allow the detection through the visible means. Of course, if any attacker can see your visible watermark, they can be detected, they can be destroyed. So this is the concept of invisible watermark, and this invisible watermark is not limited to the image only. It has a wide applicability in many applications. So hidden message can only be detectable or visible by the unauthorized entities through the some operations. So of course you have some standard techniques, some decoding techniques, and after the apply, you can extract the watermark. And of course, there is may resolve the false claim of the ownership. That's you can say the any ownership conflicts there. But negative side, you can say that it may impose the overhead on the data. Either can be overhead on the design. You can say the overhead on the signal parts. So that's invisible watermarks may be robust, fragile, and semi-fragile. So each having the different properties under the watermarking domains. So robust watermark is mainly used for the copyright protection, and it is extremely popular under this domain, data hidings domain. But there is a problem is that it cannot determine whether the content of the digital product is tampered, and it cannot be locate the tempered areas. So there is a concept of another concept is fragile watermark, and this fragile watermark is usually used for the accurate authentication, and semi-fragile is used for the fuzzy authentication. How can we use it? See, this fuzzy authentication and accurate authentication. Under the fragile watermark, it does not allow any type of tampering. Even if only one bit is changed, your data, your digital images cannot be passed the certification systems. So that's why there is a concept of semi-fragile watermark, and it is the combination of the advantages of both robust and fragile watermark. So that's why it is mainly used for the fuzzy authentications. So under this domain, images is allowed to have a certain degree of distortions, of course. And in addition to that, it can locate the tempered area as well as even restore them. And many times, in many practical applications, people need to confirm whether the images has been tempered and which area have been tempered and how to restore them. So this having the very wide applications. So anybody can propose some methods, three different type of watermark, three different type of purposes. You can hide into the images, you can hide into the video, audio, or anything. That's you can categorize this watermark is acting for the robustness purpose, watermarking for the fragile purpose, or semi-fragile purpose. That's make it a very efficient watermarking technique under this domain. So majorly starting the embedding and extraction process in the under the image domain, spatial and transform domain techniques are extremely important. And according to the software-based watermarking systems, always be spatial and transform domain approaches, and it is used in the embedding process and extraction process. These spatial domain techniques are very easy to embed the secret information under the cover media, but these techniques are highly vulnerable to the even small cover modification. That's why it is not robust. So that's why we have a concept of transform domain techniques, and this transform domain techniques provide the greater robustness of watermark data. That's why very popular for the researchers. So these transform domain techniques hide the secret information in the significant area of the cover images, which makes them highly robust to the signal processing attack. So majorly advantages of robustness against attack is transform domain. You can see the discrete wavelet transform, cosine transform, singular value decomposition. So if anybody know that the DWT is very old, not new, but if you are applying DWT into the images, it majorly divided into the four parts, and you have a four option where you can hide your data under these four type of coefficients, frequency coefficients. So this coefficients is low coefficient, high coefficients, and middle of the coefficient, low high and high low coefficient. So you can imagine that within a single image, how can we hide the four type of images, and based on your application requirements, you can hide the different type of watermark and you can use for the different purposes. Majorly used the researchers are DWT and SVD, and we have some limitations of DWT. That's why redundant discrete wavelet transform is used. So anybody can use the redundant discrete wavelet transform and contourlet transform. That's the advanced version of that wavelet transform. And similar value decomposition is extremely important in the data hiding domains, and but it is more complex. So that's why we have a concept of randomized singular value decomposition, and researchers are using particular for reducing the complexity of the singular value decomposition. So that's why you can think about that. And not only the spatial domain techniques, not only the transform domain techniques, but you can use the combination of both, and you can propose the techniques for the data hidings. Why need for image transformation is used in the data hiding? So you can see we are relating a very popular examples, and you can see any person X is on the left side of the prism, and Y is on the right hand side. So person X can see the light as a white light, however the person Y can see the light as a combination of seven colors. So you can just relate it, prism as a transform. So your transform is majorly convert the time domain to frequency domain, and this transform domain is exactly person Y is getting more information than the person X by using the prism. So similarly, a transform tool that allow one to extract more information from the signals. Of course, if you have a rich information, more information, then your processing will be easy and fast. So person X is the time domain and person Y is the frequency domain. So now this is the time of deep learning, and of course we taken this figure from my published paper, and I can show you the classical domain and deep learning based watermarking here. In watermarking, the use of deep learning approaches is extremely important and beneficial due to strong learning ability and you can say the accurate and superior results. So with this figure, you can see the cover images and watermark images. You have embedding algorithms. Either it can be transform domain, it can be a spatial domain, or it is a combination of both. So it generates the watermark images well. And this watermark images is sent to the open channels, and that's why received the watermark images, and extraction algorithm can extracted your watermark. Under the second figure, you can see here, and there is a cover and watermark images. We have an embedded network, we have an extraction network, and we are giving these two information to here, and then watermark images are generated by the deep learning models. And you are sending these watermark images over the noisy channel. That's your extraction network is based on the watermark images. It can extract the hidden media. So majorly I categorize what are the role of deep learning model in the data hiding techniques. So researchers are using, and you can see major role of the deep learning model under the data hidings. You can use the deep learning model for the pre-processing and watermark generation phase. Most of the researchers are using the deep learning model. Either it can enhance the quality of images then used for the data hiding purpose, or they can be used some models and they can generate the watermark, not using the simple watermark, using the generate watermark by the data hiding by the deep learning models, and this generated watermark can be embedded into the cover media. Secondly, you can see the optimal embedding region and optimal embedding factors are extremely important, because there is a these parameters are trade-off to each other. Imperceptibility and robustness are extremely trade-off to each other. There is an some variables in previous day, in earlier days, researchers are using some variables, and these variables is manually selected, and they can make the balance between the two important parameters, imperceptibility and robustness. However, here with the help of data hiding techniques, we can use some models. They can generate the optimal embedding factor, and this optimal embedding factor is very well suited for how can we make a good balance between the imperceptibility and robustness property. Attack simulation and watermarking extraction are important here at the receiver side. So, not at the sender side, but at the receiver side, most of the researchers are using the deep learning models. They can extract the data from the hidden from the cover media, and after the extraction, they can use also some model where they can make the extracted watermark is more similar to the original ones. So that's why you can say denoising networks are using for that purpose. And you can see the preserving textual property of deep learning models. So that's why this is the good things. How can we make our model robust? Not I am saying that the information, I am saying that how data hidings can be used, make your model robust or not robust. So there is a good research area. You can think that in addition to the deep learning model, which is extremely important in image processing tasks, but nobody is care about how can we say that our model is robust or not robust. So you can use these data hiding techniques. You can make your model robust against the attacks. So this figure, you can see here popularity and uses of deep learning models in watermarking. So under the first figure, you can see AI, ML, and DL based watermarking scheme are given, and other schemes. But out of three, AI, ML, and DL, DL based watermarking, deep learning based watermarking are extremely popular here. And out of that, other models under the second figure, you can see CNN is extremely popular for the researcher for in the data hiding domain. Now I can categorize these three techniques we have chosen for this purpose. Hopefully you can see, and this paper is published by my research scholars under the PhD work. So GAN-based watermarking for encrypted images in healthcare scenario. You can see here there is an medical images we are showing as a cover media and apply the encryption first. And we are not using the medical images, core medical images as a cover media, but encrypted images are using as a cover media. At the same time, we are using the apply the hash and hash of these medical images and patient Aadhaar number. We are combining them, and this combining text information and logo information given to the network GAN model, and this GAN model generate a logo that's called generated watermark. That's I said that. So this generated watermark is embedded into the cover media, encrypted cover media. So you can think that we are only using the deep learning model here for the generation of the watermark, and the same things we are using the transform domain and spatial domain techniques to embed it the watermark. You can see this figure. How can we embed it the watermark? We are first apply the redundant discrete lit transform and then randomized singular value decompositions. Under this domain, we are embedding the generated logo into the encrypted cover media, and this encrypted cover media is sent into the open channel. And this encryption is performed is based on the 3D chaotic map and RSVD. That's based on the diffusion process. So that's why we are encrypting the images. And that encrypted and watermarked images are sent over the open channels. At the receiver side, this network model extraction networks are prepared. So watermark extracted well by the network, and firstly logo is extracted, and this logo is given to the this network extraction network that extract the patient Aadhaar number and hash of the medical images, and we are simply the see that it is verify that it is integrity this has value for the integrity verifications. Now, what are the advantages of this? You can see the advantages is that we are using the encryption techniques, we are including the combination of two transform domain techniques, we are using the GAN model for the generation of the watermark, and proposed method is efficiently offer a very good quality and robustness, and we tested this method on a standard data sets. So that's why showing the effectiveness of that method and compared with the other state of the art algorithms. Experimental details you can see here. There is a not new. Every deep learning models using researchers that using the same things, and we are using the 80% training, 20% validations, and we are evaluating the performance in terms of visual quality. That's called imperceptibility, robustness, normalized correlations, capacity of that, and security of that. Security is majorly we are measuring by the encryption techniques. So randomness, statistical and differential test has been performed for the encryption algorithms. You can see the proposed encryption algorithm here, NPCR and USCI, these two important parameters that measure the strength of the encryption algorithms. So you can see the NPCR and USCI of the proposed method of average of 50 images of COVID-19 data set. It is 0.9976 and 0.33. It is very close, very near, it is the standard value, and it is established that if your value NPCR is 0.99 and UCI is 0.33, then it is good for differential attacks, against the differential attacks. Now it is the histogram analysis. You can simply see the test images 1 and test images 2, and after the encryption process you can see the very what are the histogram of the encrypted images, very evenly distributed entire the images. And these are the correlation analysis. These are the tested test images one. You can see the horizontal, vertical and diagonal coefficients. However, after the encryption process you can see the uniformity of the horizontal, vertical and diagonal process coefficients. Robustness evaluation you can see against the different image processing attacks, salt and pepper, speckle, Gaussian noise, and JPEG compressions. And you can see and observe that once the variance, noise density are increasing, robustness of the algorithm is decreasing. Now the performance comparison against the different state of the art is showing here. An average of 50 images of COVID-19 data set is showing that PSNR value is greater than 54. It is very similar to the original ones. SSIM is 1. It is very standard, and normalized correlation is near to 1. That say that it is the extracted watermark is very near to the original watermark. Now the second method you can see here, this is very interesting, and dual watermarking through deep learning model is very difficult, and very few researchers are published the techniques which is using the dual watermarking, which are embedding the dual watermarking by the deep learning models. So of course you can see the images are divided into two parts, and these two parts we are using the embedding networks. Two different watermarks are embedded into the different parts of the cover media. And after the cover media is watermarked images are generated and then encrypted. These encrypted watermarks are open sent over the open channels, and we have an extraction network, and based on that extraction network we can easily extracted the both watermark. Both watermark is purpose is that until now very few study have embedding the dual watermark in deep learning environments, and this dual watermarking is extremely important for the copyright protection and content authentication at the same time. So you can see how can we divide our images. We have two options, either horizontal option or vertical option. So you have images of 256 cross 256. If you are choosing the option one, we have divided into two parts, horizontal parts 0 to 127, and other part is 128 to 255, and here is 0 to 255. Let's say you are embedding your images 128 cross 128 first, because and here say under the second part you have embedding the 128 cross 128, and you are randomly selected from the bit position 5 to 132, and under the second part you are selecting with 45 to 172. So that's why what are the division key. Division key for the option 1 is 10. You are choosing the option 1, so that's why we are selecting 1. In the first part you are selecting from the 5, so that's why 05, and under the second part you are starting from 45, that's we are sending the 45. This division key is a secret key, and it is known by the receiver. We can pass them to the receiver only. Under the second option, you can see the vertically the same things are applied, and you are starting the position at the first part 25 and second part is 95. So division key is measured as option 2, 25 and 95. So our encryption process are same here. Our chaotic map are novel chaotic map RSVD, and based on this novel chaotic map and RSVD randomized singular value, uh, the in image are encrypted. So what are the major advantages of that? These are the dual watermarking techniques that propose a copyright protection and content authentication at the same time. Embedding capacity is also very high because our algorithms is embedding the dual watermark at the same time. Additional security is provided through the 3D chaotic map and randomized singular value decompositions, and the proposed method is evaluated on the standard data sets, and the experimental result demonstrate its effectiveness when compared to the other state-of-the-art methods. So here standard data sets are considering for the experiment cat and dog and cipher 10, and training and testing process is same as 80% and 20%, and evaluate the performance in terms of the PSNR, NC value, capacity in terms of PPP and security. Then the test was conducted on the various test images. We have a size of 256 cross 256 and watermark size of 128 cross 128. So you can see the visual quality comparison with the other techniques. The PSNR value obtained as 44.61 dB. However, the SSIM is near to 1, and it is always be greater than the other state-of-the-art methods. Hybrid techniques are applied it here, not the individual image processing noise are applied it, but three attacks are applied it together. And you can see the average NC value is always be greater than zero point 0.9. and it is established that if your NC value is greater than zero point 0.7, and it is very good for the any applications. Now the robustness comparison, you can see the proposed method have the average NC value is near to 1.9965. However, the NC value with the attacks are given here the always be greater than zero point 0.8. So rotation against 45-degree. But of course, there is a this it is established that if you are increasing the noise density, your performance will be degraded. Now the third methods is using the combination of biometric data hiding and encryption here, and it is very good techniques. And you can see, firstly we are taking the medical images, and we have a network segmentation network divided into two parts. You can say the region of interest and non-region of interest part, and based on the embedding algorithms, we are embedding the non region of interest part into the non region of interest part, and use of the timestamp method, we are just generated the watermarked images, and this generated watermark is encrypted by the encryption techniques. How the encryption techniques are developed? These biometric images are considered as the two images, multimodal biometrics images are considered, and the features are extracted with the network. And you can see the MAC address and secret key. User MAC address and secret key is combined here and encoded the features by the MAC and secret key. So that's encoded features are generated first, and this encoded feature are given as a seed value to the novel chaotic map. So this encryption algorithm is very efficient, and it is calculated and evaluated by the several performance metric, and this watermarked images are encrypted by the biometric features generated chaotic map. And you can see the other authentication by the this OTP authentication. Only the verified user can be use the systems, and this verified user first registered the system, and mobile number that can be matched. And if they are registered first and they are the genuine user by the OTP, it can be verified. And if the OTP is verified, then you can use the system. Now it is the best combination of segmentation and multi-biometric feature extraction network are established, that the segmented your images and extracted the multi-biometric features. Before encrypting the mark media, the multi-biometric features were encoded using the secret key and system MAC address. That's a provide the very additional security for the methods. In addition to the integrity protection, a time-based OTP authentication is used. And of course, if any user had to be authenticated by the valid OTP before accessing our systems. So this method is compared with the other techniques and showing that the superior performance compared to the other existing techniques. Now the experimental results you can see, specifically you can see the embedding bits are 7,37,751. We can embed it the very larger bit here, and our method achieve a PSNR and SSIM value is 40 more than 46 dB and 0.9944 respectively. You can see the key space of the proposed method is 2k power 2084 into 8. This is very resistive, not only for the brute force attack, but also for the very many of the attacks. So compared to the other approaches, NPCR and USCI value are more close to the ideal value. And encryption and decryption time, you can observe that this is the 0.2 second only. Now comparative analysis with the other things, you can see the proposed methods having the good correlations. Entropy is near to 8. Key space is very high. NPCR and USCI are is the standard value. Encryption time and decryption time is 0.2 second. and the PSNR and SSIM value is very well greater than 46 dB and 0.9944. So up to now you can see there is some techniques you can see, but current trends of data hiding techniques in not only the healthcare domain, but you can see in under the 3D objects, mobile devices, cloud and distributed data security, data minings. You can use for the protection of IP core and hardware design. You can use the encryption and compression and watermarking. Biometric watermarking are extremely important. You can use the optimization based data hidings, and deep learning based data hidings are also very important. Quantum researchers are using the data hiding techniques for the securing the quantum information. You can imagine the network researchers are also using the watermarking. So yes, network flow watermarking is the researchers are using the network flow watermarking, and this network flow watermark technology, that's embed the watermark information into the characteristics of the network flow, that's mark and trace the attack flow generated by the network attackers. So actually, this network administration takes the advantages of the traffic analysis for the purpose of security, intrusion detection, or traffic shaping, etc. So that's why network flow watermarking is also very new. And these data hiding techniques are using by the researcher to make the robust your model in addition to the informations. These are the some potential issues and possible solution I categorize here. So need to investigate some approaches that will improve the multiple performance parameter at the time, robustness, imperceptibility, and capacity. Security and computational cost is extremely important at the same time. So I suggest to researcher these five property you can make in a single methods. They can make a good balance between all five at the same time. While developing a new watermarking or improving any existing techniques, the different type of possible attacks on the image should be considered. Need to address data management issue. Most of the researchers are using only the trade-off, make the balance between these two, three parameters. At the same time, you can use the data, address the data management issue and categorize your data, which one is more important and which one is less important. Complete security of the medical and non-medical data and hide significant information in a minimum time are equally important. For the real-time application, you can see the chip and hardware security, hardware-based watermarking techniques should be developed. Most of the medical image watermarking is dependent on the size of the ROI and NROI part or the size of the cover media. But you can think that how can we hide the information which is much larger than the size of the cover media? Yes, there is a multiple papers are published under this domain. You can see how can we hide as much as information that's a greater size than the cover media. And most of the technique only detect the tempered area in the images. We can see the multiple paper, many of the papers that detect the tempered area, but how can we correct them? There is a important parameters. You can publish paper, you can propose technique that can temper, that can identify the tempered area and correct it. Most of the researchers are using encryption and compression. Of course, in the image processing operation, this encryption compression is very important solutions. But along with that, watermarking, there is the three possibilities: either encryption before compression, compression before encryption, or joint encryption compression. That's a very good choice. So based on the application requirement, you can think which can be applied it first. And of course, each pair having the different uh, advantages and limitations. Either encryption before compression, compression before encryption, or joint compression, encryption compression at the same time. Suitable error correction code can be required to the reduce channel noise distortion. So most of the researchers are using the turbo code, and this turbo code is extremely important, and it is better than the BCH and Reed Solomon code. So you can design your own error correction code that can be better performance than the turbo codes, or you can design your hybrid of some error correction code that make it efficient and reduce your channel noise distortion. Optimization scheme is extremely important under this domain that make a good balance between the imperceptibility and robustness. So that's why it is very important, but it imposes the extra overhead in the watermarking procedures. Hybrid of two transform domain techniques, soft computing, blockchain, and it is used to enhance the performance, but it increases the computational complexity. So biometric and blockchain-based watermarking is a good choice for the healthcare data security. However, you can think about how can we reduce the cost at the same time. Up to now, machine learning and deep learning has provided the significant contribution to the watermarking scheme. So we have categorized some issues. You can see most of the scheme did not significantly provide the security solutions for the media and deep learning models simultaneously. You can see either researchers are using the security solutions for the informations or security solutions for the deep learning models. So you can think how can we propose a method which can provide the solution, security solutions for the media as well as the deep learning model at the same time. Most of the existing methods have the proposed watermarking through the insertion of single watermark. As I said that you can think about how can we make our model that can embed the dual watermarking and extract dual watermarking at the same time, which are very important for the ownership verification, copyright protection, and content authentications. Most of the technique trained their deep learning model in such a way that raw data shared by the client that led the privacy issues. So most of them are using this type. Raw data is shared, but you can think how can we use the other things. Either you can think about the split learning, right? Federated learning. So split learning is popular. You can train a model without sharing the raw data. And under this split learning, data is kept on the local devices and only the model updates are shared. So that's why it is addressing the data privacy and security issues, and at the same time targeting the reduction of the computational and communication cost. So you can think about that. You can think about the how can we merge, how can we combine the federated and you can say split learning model, which can be suitable for the private addressing the privacy issue or addressing the reducing the cost also at the same time. Many of the researcher may use the concept of the coverless steganography. So most of things published paper based on the covered steganography, but you can think the coverless steganography that's provide the unreadable and invisible property for the data hidings. So the researchers are proposed the feature dependent coverless steganography. They are extracting the feature and match them, but which is insecure and need high storage cost. So we can design a feature independent based coverless steganography method for the effective data hiding. And it is a very good problem. So you can think about the you can take a model, you can design a model which can be used for the coverless steganography. So these are the some professional activity I am doing that, and I am inviting you if you are a good researcher under this domain. So we have a, guest editorial here, and we are managing some SIs in IEEE transaction on consumer electronics and Journal of Biomedical and Health Informatics. So I welcome your submission. If you have a good paper, you can submit there. So these are my research paper under the Google Scholars. So if anyone are interesting to work with me, you can contact me on my email. You can see my papers, and if you are interested for that, you can contact me. So these are the some AD scientific index, and my recent books are there. So thank you very much for your patience, and I think I finished in 1 hour.
Thank you very much, sir, for your wonderful talk. on data hiding. Uh, Participants, if you are having any queries, you can write it in the chat box. Sir, can you open your chat box or shall I read the comments? I mean the queries.
Hello.
Yes, sir. Yes, sir. So there is a query in the chat box by Pradeep. Sir, I have an input image. I have applied some image enhancement technique. How can I determine whether my image improved or degraded in comparison to the original image, or improved or degraded? Okay.
I
In
cannot
comparison to the original, what
see.
is
I
okay? What
cannot
is
see.
PSNR SSIM value indicates the
Yeah,
improvement or
sir.
degradation?
Dr. Deepak, please share with me the question.
Sir, can you open the chat box, sir?
Okay. Okay.
Chat box icon is there, sir, in the right hand side. In the extreme right hand side, sir.
Yeah. Yeah. I have an input images. I have applied it some image enhancement techniques. How can I determine whether my image proved to degraded in comparison to the original image? What is the PSNR as assignment? Yes, you can use PSNR is a very good quality metrics. The evaluation of the quality of the images. So either if you have a input images and you are enhancing the images, of course your PSNR will be better. Okay. And if you are degraded images, then your PSNR will be less. And it is established that if your PSNR is greater than 30 dB, then it is good for the operation. Otherwise, it will be not good for the any applications. Either you can use the PSNR, SSIM, or weighted PSNR. Any others?
Yeah, participants, if you are having any other queries, please write it in the chat box. Uh,
Okay, I think there is no query.
mm, uh, there is one more query, sir, by the same participant, Pradeep.
PSNR, yes. What is the PSNR of original images in this case? So you can always be PSNR is always be evaluated between two images, right? First
Yes.
one is original, second one is after the operation. Either it can be compression, either it can be encryption. So always be evaluated by two things. So you make ensure that PSNR is always be evaluated between two images. Okay.
Yeah. Yes, sir. Yeah. Sir, thank you very much for your wonderful lecture on the data security, especially on images and videos. And I thank you for accepting our request and delivering a wonderful talk. I, on behalf of the E&I ICT Academy, and you are, I think, also one of the E&I ICT Academy among the 7 E&I ICT Academy we have across
Yeah, yeah.
our country. So thank you very much, sir, for accepting a request and sparing your valuable time with us. Thank you, sir.
Thank you, Dr. Deepak. Thank you.